Hello everyone and welcome to the first WEISS surgical standoff. Thank you all for coming along. My name is Simon Watt. I will be your host for this evening. We're here with an audience right now on Zoom and we'll be recording it and we'll be showing it again on YouTube afterwards. Should anything technical go wrong this evening or we're interrupted by children or cats or any other interruptions if they make an appearance, and let's be forgiving. And my kids don't know that I call them the interruptions, but that's the times we're living in. It is but a minor blip in an already confusing and frightening year. If for some reason my feed should get cut off, I'm aided and abetted by Dan Taylor. Dan, could you give everybody a wave now? He will swiftly sweep in and take over, and we're also joined by the comms manager, Amy Warnock, who will keep an eye. I'm the Public Engagement Officer at WEISS. That is the Welcome EPSRC Centre for Interventional and Surgical Sciences at UCL. The centre exists to combine the strengths of engineering and clinical science at UCL and to ensure that the innovations and the engineering solutions that we're working on are reaching the clinic to benefit patients. We are joined tonight by 6 WEISS researchers. They're here to play a game that will allow them to share some details of their research, while also illustrating the competitive nature of the research world. Not only do scientists have to do pioneering work, but they also have to be able to convince funders that it is their work that is most essential. Good ideas do not get funded because there are people out there with better ideas who are at least better about talking about them, or something like that. That's the world we live in. So before we kick off, we're going to meet our contestants. Can you please introduce yourselves now with a quick sentence about who you are? Let's please start with Ellie Martin. Ellie, can you please unmute yourself and tell us who you are?
Hi everyone, I'm Ellie Martin. I am a research fellow in the Department of Medical Physics and Biomedical Engineering, and I research therapeutic uses of ultrasound.
Thank you, Ellie. Over to you, Erwin.
Hi, my name is Erwin. I'm very happy to be here tonight. I'm originally from the Netherlands and a physicist in training where I've studied virtually all aspects to do with sound. I have been at UCL, University College London, since 2014 and was fortunate enough to land a lectureship position at WEISS from February.
Fantastic, thank you. Over to you, Fraye Watson.
Hi everyone, I'm Fraye and I am a second year PhD student at the UCL CREATE, which is the Centre for Rehabilitation Engineering and Assistive Technology. My PhD is looking at using wearable devices to monitor outcomes in patients with scoliosis.
Thank you, Fraye. Can you please introduce yourself, Rawen Kader?
Hi, my name is Rawen. I'm a gastroenterology registrar by trade, so I'm a doctor. I'm a second year PhD student and my interest very much lays in using artificial intelligence to improve the quality of colonoscopy.
Thank you very much. Over to you, Jeremy Opie. Opie.
G'day, my name's Jeremy. I'm an Aussie. I'm also a human factors engineer and a postdoctorate working in the WEISS Centre. And
our final contestant, Sophia, Bano.
Hello, I'm Sophia and I'm from the WEISS Centre. I'm a research associate in the surgical robot vision group led by Dan Sternoff, our director of the center. And I'm mainly working on developing artificial intelligence algorithms for improving surgical outcomes, specifically to endoscopy vision.
We'll be hearing a lot about this research, and you'll be hearing from these researchers, some more than others, because each of them will be given 1 minute to convince you that their research is the most important. I have my stopwatch at hand. Then one of them will be voted off. We will repeat this process until only one researcher, tonight's winner, remains. There's no real jeopardy here. No one's going to lose a job. No research is not going to happen. But the winner will no doubt be looked upon with envy and disdain by everyone when we can finally all get back to a lab or be in the same office again. Deciding who we're going to kick out after each round, we have our illustrious judges. So please, can you now introduce yourselves? Let's start with Edge Kader.
Hello everyone, I'm Edge Kader from the Fitzrovia Centre, a community centre in Camden and Westminster. Our lovely building in Fitzrovia has been closed, but we've moved all our events online, so if you want to hear the poetry, come and join us.
Fantastic, thank you. Could you now introduce yourself, please, Beverly Power?
Good evening, everyone. My name is Beverly Power, and I'm the current chairperson for the UK registered charity CDHUK. I'm also a founding member of Idea Alliance, which is an alliance supporting patients and clinicians, in fact, anybody affected by diaphragm and abdominal wall anomalies. I'm going to do a little bit of a plug and tell you that we are working on an exciting project ourselves at the moment and are hoping to soon release version 1 of our mobile app to support patients, families and clinicians of patients with congenital diaphragmatic hernia. Good luck, everyone.
Could you please introduce yourself, Luke Buffery?
Hello everyone, I'm Luke. I'm from Healthwatch Islington. We're a charity that champion the views of local people about health and care. And we've been working with the research team at UCH to deliver health-focused Zoom events during lockdown.
Fantastic, thank you. And please introduce yourself, Cristina Serrao.
So last but not least, I hope. So I'm Cristina Serrao. I'm the lived experience ambassador for the Experience of Care team at NHS England. I'm also an allied member of the UCL Centre for Co-Production and lots of other hats, but I won't bore you. Good luck, everyone.
We will need it. We'll do our best. We should also be joined tonight by Leslie Booth, who is representing the Bile Cancer Research Charity, but unfortunately she's taken ill. So let's best kick off. Thank you, judges. Though they will get to decide which of the researchers bite the dust, if there is a tie or something, we will open it up to everyone in our poll. And everybody here will also have an opportunity to ask our researchers questions if they wish. If something does occur to you, then please pop it in the chat. Either Amy or Dan will read out your question, but please tell us who that question is for. I'll try and keep my eye to it as best we can as well. So, let the games begin. I'm getting my stopwatch ready. We're going to start with Ellie Martin. Ellie, when you are ready, can you please start telling us why your research is the most important in a minute or less? On your marks, get set, go.
Okay. In the UK, 1 in 6 people have a neurological disorder of some sort, so like Parkinson's, epilepsy, or Alzheimer's. And these are all horrible diseases, often treated with long-term drug use. And that can leave patients with serious side effects, and sometimes in the end the drugs stop working. People are also sometimes treated with brain surgery, but that's obviously very risky and difficult to recover from. So what if we had a drug-free, surgery-free treatment for some of these diseases? My research is currently focused on developing a device that can treat some of these diseases using ultrasound. It has little or no side effects and without the need for any surgery or drugs. Ultrasound is sound at a frequency above the pitch of human hearing. It's usually known for taking pictures of babies in the womb before they're born, but it can also be used to perform treatments in different ways for lots of different conditions. By focusing ultrasound through the skull, we can modulate the activity in the brain, sort of suppressing some areas or increasing other areas, and treat some of these disorders. So this is called transcranial ultrasonic neuromodulation.
Perfect, thank you very much. So that was a yes, your minute is up, Ellie. Next, we are going to go to Erwin. Are you ready, Erwin?
I am, yes.
Take it away then.
Thank you. Minimally invasive surgery is a form of surgery where only small incisions are made to insert miniature instruments. The tips of these instruments are then guided to remote locations, and interventions are performed at the far end of the instrument through manipulation at the near end. So this results in less scarring, quicker recovery, fewer complications, and reduced overall cost to the patient. However, due to the overlying skin and organs, surgeons can no longer directly see what it is they are doing. So minimally invasive surgery can thus be compared to a high-stakes game of electric bowels wire, but one where the loop is a meter long, surgeons are blindfolded, and sounding the buzzer actually harms the patient. So to give surgeons a fighting chance, I am developing miniature optical ultrasound sensors that provide crucial visualization of both the tissue surface and what lies underneath directly from within the instruments.
Fantastic, thank you so much. Next up, Fraye, are you ready?
Yeah.
Take it away.
So many health conditions can change how a person is able to walk, navigate, or interact with their home environment, such as Parkinson's disease, spinal deformity following a stroke, or when using a prosthetic limb. And I'm sure many of us take this ability for granted every single day. Information about how a patient performs their usual activities of living is taken by many medical professionals to monitor the outcome of various interventions. And a lot of this information might be taken by questionnaires, by functional tests or movement analysis in the clinic. And these tests are invaluable, but they're not performed under the conditions that a patient usually experiences at home. For example, floors are very clear and flat. They might be walking on a treadmill, and they're under pressure to perform really as well as they can. For example, carers of Parkinsonian patients often report that they don't usually walk this well at home. So my research is about using a wearable device, such as a smartwatch, to take the patient out of the clinic and use their normal movement at home to monitor their clinical progress and provide objective data to the clinical team.
Sorry, I did that thing where I left my mute on, didn't I? Forgive me. It was bound to happen to one of us, and the fact it's me, I hope it's the rest of you at ease. Rowan, it is your turn. Please tell us all about your research in a minute or less.
Fantastic, thank you. So I'm a doctor by trade, and one of the most difficult things in my practice is giving a diagnosis of cancer to patients. So it's something I'm very much interested in, particularly in colon cancer, given my specialty of gastroenterology. So really what my research is about is trying to improve detection of cancers, and more importantly, trying to actually prevent cancers from occurring. So at the moment with colon cancer, the way that we try to prevent cancers, we have a colonoscopy, which is a camera that goes in the back passage and has a look at the actual colon to see if we can see any lesions. But unfortunately, we know that up to a quarter of lesions can be missed during colonoscopy. So what a lot of my work is using artificial intelligence to try to improve the performance of endoscopists to help detect polyps whilst giving live feedback of what the actual diagnosis of the type of polyp present. And as with all good research, I'm also trying to do a background review to find out what the actual rate of missed cancers are across the whole world. So vote me in and I'll tell you a bit more about the AI side of things.
Very tempting, thank you. Jeremy, your chance, 1 minute starting from now.
So g'day, yeah, I'm a human factors engineer, which means I work with users that find technology to assist them. I worked on a project where I was asked to develop an interface to control a continuum robot to perform minimally invasive knee surgery. My first thought was, how does a surgeon need to control a continuum robot, which is a robot that moves like a snake? Thinking about this led to another question though, what task is it the surgeon needs the robot to perform? This then led to another question, what are the current limitations with knee surgery that a surgeon requires the assistance of a robot to perform? This core question allowed me to open up a discussion with orthopedic surgeons in which we were able to identify the key limitations that then allowed to answer the previous questions with more confidence. Working with surgeons, I was able to develop an interface for a robot that was performing the tasks that surgeons needed with an interface that met their requirements, that improved on current limitations. And it's by working with the people that I was able to develop something that worked for their needs.
Fantastic, thank you, Jeremy. And now, finally, for this first round, Sophia, please take it away.
Yeah, so we all have smartphones and we all like taking panorama pictures whenever we go on a holiday, a spot like this in my background. So, but have you ever wondered that this can be an application beyond just taking panoramas from our mobile phones? This can be a very useful application for surgical stuff, for endoscopic vision, for improving the endoscopic vision during the procedure, because the field of view in endoscopy is quite limited. So the surgeons at times struggles in localizing anatomical structures, but we can build smart softwares that can stitch the endoscopy video images together so that it can create an image with a larger field of view, which can then help guide the surgeons during the procedure, and it can also improve the surgical outcome. So yeah.
Thank you very much. Well, I know you can't hear us all, but I'm going to give us a virtual round of applause. I think that was fantastic. But one of you has to be voted off. Before we get to the votes, I'd like to say thank you to our audience out there. I can see there's already fantastic questions coming in. We'll definitely try and get around to as many of them as we can at the very end, or as each of these people is voted off. Dan and Amy, please take note of some of the really good ones I've seen already coming in. Check them out. I'd love you to voice them. So the way that our judges are going to say goodbye to the researcher that they don't want to hear any more from is they're going to give them a wave. So I'm going to call out that researcher's name, and you're going to wave them off. Yeah. Sad as it is, as we can see, this is all proper good research which will change the world and may already be changing the world. But even good ideas often don't get funded. We're after the pinnacle. We want to see what the best is. So, if you would like to vote off Ellie, then please give me a wave now. Was that a stretch, Cristina, or is that a wave?
Yeah, I just sort of wind up. It's a stretch.
Fine. So Ellie is definitely through. Erwin. Any votes against Erwin? Erwin is through. Any votes against Fraye? No, you could feel that. I know that you're all on mute, but I can still tell you're holding your breath. Any votes for Rawen? Oh, Beverly has cast 1 vote for Rawen at this stage.
You see all of us.
And Cristina. And is there anyone else? Okay, and now any votes for Jeremy? 1 vote from Luke for Jeremy. And from Echo. Oh, okay. In that case, we can say you are safe, Sophia. And we can say that it is currently a draw. Now, Dan, have you been able to edit our poll fast enough back there? Or can I launch it and explain to our audience how it works? You've edited it. Right. I am going to launch a poll for everyone. It does have all panelists in it, as far as I can tell by looking at it here. I want you to either vote for Rawen or for Jeremy. You're voting for the person that you want to kick out of the competition, that you don't want to hear anything more from. I'm launching the poll now. Dear audience, please cast your votes at this very minute. I will warn you, this will hurt some people's self-esteem, in particular Erwin, because he's safe, and some of you voted for him. We're going to give you 10 more seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Erwin, no, sorry, Jeremy. Sorry, it is bad news. You have been cast out. It's the audience here. You don't have to blame our amazing charity judges. Jeremy, before you go, please tell our judges, and more importantly, all the people at home, why they've made such a hideous mistake and why you deserve to keep your job and keep doing research.
Okay. One of the biggest problems that gets made when engineers are designing things is they don't think about the users. They don't think about what the users' needs are, and they design the incorrect thing for the people. So my research is about going to the users and finding out exactly what the problem is, identifying that, and then developing the technology that allows them to be able to overcome these limitations. So without knowing this, we're constantly designing things that don't get used or get used improperly and just get put to the side.
So basically you're saying these people have voted for wastage?
Yep.
Yeah, okay. Well, I can tell there, yeah, he thinks you made all the wrong decision. Before we say goodbye to Jeremy and he's forced to switch off his camera and we never see him ever again, has anyone there got any questions for him? If you do, please cast them now. And Amy and Dan, if you see anything in the previous questions, please ask us. I'll give you a few seconds from that. Or maybe you want to hear so little of him that there's no questions either. This is damaging the self-esteem, isn't it? You thought this was just a nice public engagement exercise, but now it's got personal and mean.
I'd like to know more, by the way, so you can get in touch with me afterwards. I'd like to know more.
Actually, we've got a general call out from both Cristina, but also from Monica, who would just like to hear more about what you do in general. Can you tell us a little bit more in Jeremy? What is like your day-to-day?
So I work with people. I perform interviews. I do. I have group discussions. I do workshops with people to understand exactly what's going on. So I can kind of put myself in their shoes, so that when I'm looking at technologies that can assist them, I can do it from their perspective and their understanding. And then when I have these technologies, we then go and work with them iteratively to design the systems that are going to work specifically to help them with their problems.
There you go, everyone. That's what you said no to. So Jeremy, would you please switch off your camera? Jeremy might now be invisible to us, but the good news is he is still there in the background. If you have any more questions for him directly, feel free to type them in the chat, and Jeremy, I'm sure you might be able to answer them personally as we continue all this. And he'll also be back at the very end, where we can ask anybody and everybody questions if we wish. So round 2 kicks off. This time we're going to start with you, Sophia. Please tell us in a minute or less, I've got my stopwatch, why your research is important. Go.
So have you ever wondered how these Snapchats or face messenger filters work? Or for instance, how autonomous driving vehicles, they work, or a very basic example at the airport on arrivals, immigration, there are automatic gates that scans your face and passport and let you go through. So these are all real world examples where AI is applied, artificial intelligence is applied. These can be applied in clinical settings as well. And what I work as the second topic of my work is improving the surgical outcomes by, while during the endoscopy, helping surgeons identify suspicious tissues or even important sites or anatomical sites which might be important or they have early signs of cancer. So since I said in my previous session that the field of view is narrow, at times there is a slight possibility that the surgeon can miss some lesions while they are scanning, but the AI can drive this. AI can alert the surgeon when there is a suspicious tissue which they are scanning and then can help the surgical outcome.
Thank you very much, Sophia, and the best use of a Zoom background that we've yet seen. Really good. Going over to you now, Rawen, please take it away. In a minute or less, tell us why your research is the most important.
Hi, so as I mentioned, 1 in 4 polyps are missed during colonoscopy, and these polyps can develop into cancer. So what our team's doing is we've developed a software using artificial intelligence to actually detect these polyps in real time. And why this is important is it means that during the colonoscopy itself, if you see a polyp but your eyes miss it, which we know happens during colonoscopy, this AI system will detect it in real time, flash up visually in a bounding box, and it will also notify you audibly in the form of a sound alarm. So the aim of what we're working on is actually to try to reduce the amount of polyps that are being missed during colonoscopy and then reduce the number of actual colon cancers that are occurring in the population. The second part of our research is also actually being able to assess the polyp in real time. So rather than removing it and sending it to the lab, what we're actually doing is we're teaching, using an AI system, we're actually diagnosing what the type of polyp is, i.e. the type of lesion. And by doing this, it means we save money for the NHS, and we're also able to improve anxiety for patients by giving live feedback in terms of diagnosis right after the procedure. Thank you.
Thank you very much, Rawen. Over to you now, Fraye.
Thank you. So my research is focused on balance in patients with a spinal deformity called adolescent idiopathic scoliosis. Scoliosis is a sideways curvature of the spine. If you had X-ray vision goggles and you looked at someone from the front or the back, their spine would look S-shaped when it should actually look straight. The adolescent idiopathic part means that it happens when you're about between 10 and 16 years old, and that we don't really know why it happens. Research suggests that patients with adolescent idiopathic scoliosis are worse at balancing than healthy adolescents, and that this difference increases the bigger the curve gets. And so my research, we work towards using a wearable device to measure balance during activity at home. And this will allow us to monitor the improvement or worsening of a scoliosis leading up to or following a treatment such as physio, brace, or surgery. Monitoring patients at home has recently become very important due to the coronavirus pandemic, as we're trying to reduce the amount of time patients spend at hospital. And I'm confident that wearables can help us there too.
Thank you very much, Fraye. Erwin, you're up next. 1 minute or less, tell us why your research is the most vital.
As you can imagine, in minimally invasive surgery, space is limited and instruments are, in addition, treated as single-use disposables. Imaging probes just need to be less than 1 millimeter in diameter, as well as inexpensive. Optical ultrasound can deliver this. So with this technology, sound is both generated and detected using light. So you may have all suffered delays in summer when your train is delayed because of warping of the railway tracks. So optical ultrasound uses the exact same principle. Light is shown onto an optically absorbing coating where it is converted into heat. The coating then expands, and that motion generates the sound wave that we use for imaging. So compared to clinical ultrasound systems, optical ultrasound offers a high bandwidth, which translates into a high image resolution, as well as a large imaging depth. In addition, Optical ultrasound sensors are relatively easy to fabricate using household materials such as bathroom caulk and candle soot. So optical ultrasound is hence ideally suited to minimally invasive surgery.
Simon, you're muted.
Oh, I've done it again, haven't I? Ellie, please take it away. Tell us why your research is the most important.
Hi, so what about the cost of treating brain disorders? So whether you're using ultrasound or any other method. So 1 in 6 people in the UK have some kind of neurological condition, and we have an aging population, so that's only going to increase. But there's also 1 in 6 people suffering from psychiatric disorders like depression or OCD. And this kind of ultrasound treatment could also be used to help those people. So the cost of treating all of these people in the UK is thought to be more than £100 billion every single year. So that goes into NHS costs like the doctors, the cost of surgery, the time that people spend in hospital, the drugs, the aftercare, the treating the side effects, and then also losses to the economy when people miss work. So the cost would be cut massively if we used ultrasound. For example, sometimes you might use a surgery to implant a wire into the brain to regulate the activity in epilepsy or something like that. And there's a risk of infection and long recovery time, so it's expensive and it carries a lot of risk. If we used ultrasound instead, then within a few hours or a day, the treatment could be done to stop this activity. It'd be a one-off treatment and there's no stay in hospital, there's very little recovery time, and less care is needed afterwards.
Fantastic, thank you. That is our second round. Again, some virtual applause for all of you. Well done. But here comes the harsh voting. So, if you would like to vote off Ellie, please wave her goodbye now. Ellie, you are safe. If you'd like to vote off Erwin, please cast your vote now with a big wave. Cristina, you keep moving your camera just at that time to kind of like psych me out.
I dropped it, sorry.
Yeah, you're just adding tension. I love it. Okay, Erwin, you're safe. If you'd like to vote off Fraye, please give a big wave now. Fraye is safe. So, if you'd like to vote off Rawen, please cast your votes now. Rawen is safe. Oh no, we've got one vote for Rawen from Cristina. Thank you, Cristina. So I think I know how this is going to go. If you want to say goodbye to Sophia, give her a wave now, please. Are you abstaining, Beverly? Or have I missed it? Fair enough. I'm afraid, Sophia, bad news. You're now cast out of the competition. Can you please unmute yourself and tell all these people why they made the worst decision possible and why your research is, to put it mildly, the best and better than everyone else who's here?
Yeah, I was coming to the main exciting part of my talk, which was about fetoscopy surgery, which is the most delicate endoscopy procedure. So my algorithms are designed for treating or helping during endoscopy procedures, during fetoscopy procedures, specifically increasing the field of view, helping find important sites for the surgeons by overlaying vessels, overlaying important information during the surgery. So I believe this has a lot of impact in clinical practices in next coming years once we move on to the feasibility trials.
Dan, I can see we've got some questions in the chat. Would you mind telling Sophia what they are?
Yeah, so we have one specifically for Sophia. It's quite a specific one, so we might have to break it down a little bit. It's asking about what kind of algorithms you're using in your case. Is it mainly convolutional neural networks or something else? A lot of us, including me, are not scientists. So can you tell us what a convolutional neural network is and how it works?
So we are using convolutional neural network as well, and we are also working with classical methods as well. CNN or convolutional neural networks is composed of linear layers to break it down, and it has it can go very deep as well. So by training these networks, so for training these kinds of networks, we need big data. We are building databases as well. So for training these networks, we need this data. And once we start the training, these networks have kind of layers, kind of filters on them, which we want to learn during this training process. And these during this training process, they get refined to this stage that once some new data comes in, the network can output the most feasible or most effective solution. So yes, I'm working on convolutional neural network. I'm working on other computer vision related stuff as well. Yeah.
I doubt that was a lucky guess, Jay. Thank you ever so much. So I think we have to get on to our next round. Sophia, could you please ceremonially switch off your camera? It's been lovely talking to you, but goodbye. So, round 3. And then there were 4 contestants. Can we please start with you, Fraye? Take it away. You have 1 minute to convince us that your research is the most important.
Hopefully my speaker is working a bit better now. So last time I explained that adolescent idiopathic scoliosis is a sideways curvature of the spine. And the reason that I'm interested in it is because it's the most common spinal deformity, and it mostly affects girls between the ages of 10 and 16 years old. If left untreated, the curve will continue to get bigger until the patient stops growing. And this could result in anything from a very small curve that you'd need your X-ray vision goggles again to see, but it can also result in a very large curve that can deform the patient's body, decrease their lung capacity, and limit their ability to walk. The best way to monitor scoliosis is using X-rays, but because these patients are monitored over years at a time, this can mean a lot of them. Research has shown that girls with scoliosis are more likely to develop breast and ovarian cancer, which is likely due to the multiple X-rays they had as children. And this has been noted by a scoliosis charity as one of the top 10 most important areas for research. So with the extra data collected from my wearable device, we could help clinicians reduce the number of X-rays a patient needs because we're providing them with an additional objective monitoring tool.
Thank you so much. Erwin, please take it away. Convince us all.
All right, so imagine you're looking to purchase a new TV. You have received an advertisement in the post highlighting a good offer. But would you straight away run to the shop and buy this? Probably not. You would read customer feedback, read professional reviews, possibly check social media to get a better idea. So the same is true with medical imaging. One image is often not enough. We want to use multiple devices and combine all their advantages to get the best possible image quality and the best possible diagnosis. This so-called multimodality imaging can be very, very powerful, but it is often simply not possible due to what is called electromagnetic interference. So you may know what happens when your mobile phone rings right next to a loudspeaker. You get this annoying crackling sound comes out of your speaker. So a similar effect occurs in medical imaging, where the presence of one device can negatively impact the performance of another device. Optical ultrasound imaging sensors are inherently insensitive to this interference and are hence perfect for multimodal applications during, for instance, MRI imaging and radiotherapy.
Thank you very much, Erwin. Let's go to you now, Rawen.
Hi, so as I mentioned, the main goal of what I'm doing, or what my team is doing, is we're trying to reduce the amount of polyps that are missed during colonoscopy, and hoping as a result of that to reduce the amount of colon cancers that are developed in the population. And just to add to what was mentioned earlier, we are using convolutional neural networks as well to train the AI systems for polyp detection and what we call optical diagnosis of polyps. And the reason why I would say my research is important is I'm not just doing the preclinical phase, because we know that less than 25% of preclinical research makes it to the actual clinical arena. So as part of my research, I'm also setting up a multi-center trial recruiting 654 patients from over 8 NHS hospital sites to actually test our 2 AI systems and to actually answer the question, which is what we're developing helping the patients, and is it doing what it's supposed to do? Thank you for your time.
Thank you very much, Rowan. I'd also like to just pitch in and say right now, I can see that people in the chat are also talking to each other. We've got all kinds of brains out there, so feel free to ask each other questions and things there. If you've got anything for our panelists, stick their name in it so we know who it's going to. And our final contestant for this round, Ellie Martin. Please tell us why your research is the most vital.
Okay, so why is ultrasound better than other similar technologies that we could use for these treatments? So the idea is that one of the ways we can use ultrasound is to stimulate activity in the brain by pushing on the brain cells a little bit. But there are other ways of doing this non-invasively, so from the outside without surgery. You can use strong electrical currents or strong magnetic field, but the problem is with these is that they don't target a specific region of the brain. So they basically, if you're using electrical stimulation, almost half of the brain is exposed at the same time. So you don't have this kind of control. So even within different ultrasounds, there's some variation. So different systems, so for example, with a simple setup, there's no focusing or correction for the distortion that the skull causes to the ultrasound waves. So that means that different regions of the brain might be exposed in different people, different size of the target, and it will vary from person to person and treatment to treatment. But with our system, we can do accurate targeting, so zooming in on small millimetre-sized regions with millimetre accuracy. We can correct for the distortion that's caused by the skull, and we know how much sound is going where and how much sound there is and where it is. So it's more specific, it's less likely to generate unwanted side effects, and it's a more useful tool that we could use for exploring the function of the brain as well.
Thank you very much. So somebody has to get kicked out. Judges, I'm going to go through each of the people, and could you tell us who you would like to vote off with a wave? So let's start this time with Rawen. Would you like to vote off Rawen? Give us a wave now. 2 votes cast, 1 from Bev, 3 votes cast, 1 from Edry, 1 from Luke, and 1 from Bev. So this is now entirely academic. Sorry, Rawen. Any votes for Fraye? Any votes for Erwin? Any votes for Elly?
I'm staying out of it now.
Very wise, Cristina. Cristina's deciding to abstain whenever the outcome.
He convinced me as well. You know, I voted him out twice. He convinced me and didn't convince everybody else so well.
I'm very sorry, Rawen. Well, you know, at least you, Cristina, for you, can you tell us all why Cristina was right? Can you tell us why your research is the most fundamental?
Yeah, absolutely. So I think the reason for why my research is important is I'm really following the journey. The academic journey. So I'm not just doing the preclinical research. I'm using my experience as a doctor and working closely with computer scientists to actually help develop a product preclinically and actually putting it inside the actual arena, i.e. where patients are. And that's really the only way that we know whether something works, is by assessing these things in robust clinical trials. So I think my research is important really twofold. One is you're doing the start part of the journey of developing the product, but the most difficult part of actually being able to assess it in the actual clinical arena. So that's my 2 cents.
Well, yes, very convincing. Audience, though, have you any questions? Do you think has this been greatly bad? Amy, a question's come in. Would you mind please relaying it to Rawen for us?
Yes, we've got a question from Shay, who wants to know, what do you see as the future of the role of medics if the majority of tasks become automated?
So very, very good question. It's something that doctors worry about a lot. From my perspective, I have 2 key points to say on it. Firstly, it is correct that as as technology develops, more things will become automated. But that doesn't mean that our role as doctors become defunct, because what it actually means is that we get to spend more time with the patients. Because as doctors, we want to automate a lot of the work that we do, a lot of the paperwork, which takes our time away from patients. So I don't see it as a negative. I see it as a positive. The more automation, the better, because the more time we can actually spend thinking and talking to the patients. Because, managing a patient isn't just about managing their disease or treating their disease. It's actually looking at the whole picture and treating the patient as a human. So I think it's a big bonus.
You got 2 thumbs up from Cristina for that, Rawen, which is very pleasing. And I'm glad to see that there's not going to be any Luddite surgeons going out and smashing the robot aids as time goes by. Have we got any final questions? And yes, Fraye, we've got feedback. Yes, your sound was much better. We don't know what was causing that, but the headphones maybe were scratching on something. Is there any final questions for everyone? Okay, then we're into, we're getting near the end.
Thank you all for your time. Thank you.
Thank you very much. Yes, goodbye.
Bye.
Please switch off your camera as well. We don't want to look at the losers. We will be seeing them all again later, and we'll have another chance to ask questions. If you do have questions, remember, pop them into the chat, or you can see there's a Q&A bit. I've registered this one question. We'll make sure to get to it at the very end when Jeremy's allowed back in the room. But until then, let's kick off with our next rounds. Elly, tell us in 1 minute or less why your research is the most important.
Okay, so what else can we do with our ultrasound system? As well as treating brain disorders with fewer side effects and little recovery time and lower costs and more specific targeting and all of the other things that I said before, a lot of the work that we've done on building the system has gone into getting the sound exactly where we want it. So knowing how much there is, what the dose is to the patient, and making sure that the patient is properly positioned so everything goes in the right place. So if we use these principles in this system, then we can treat different things in different ways. So we can increase or decrease activity in the brain. or destroy small regions in a really controlled way to stop activity completely, which is something, if you Google it, there are some really good videos about essential tremor. But another difficulty with treating the brain with drugs is that the brain is protected by something called the blood-brain barrier, and is protected from infection and harmful substances. And it's difficult to get drugs through it, basically. But you can use ultrasound to open up this barrier and let drugs through in specific places and control how they're released. We could also use it for neuroscience to explore the workings of the brain, for example, stimulating one part of the brain and seeing how it's connected to other areas.
I did again. Thank you very much, Ellie. Over to you, Erwin.
All right, so far I've only discussed the technology behind optical ultrasound imaging, but what can we actually use this for? So in a nutshell, any application where you would need high resolution images, but space is severely constricted. So applications are envisioned in a range of areas, such as cardiovascular disease, where we can assess plaque burden, inform or confirm stent placement, and monitor radiofrequency ablation of atrial fibrillation. In fetal interventions, we can provide guidance and monitoring of optical ablation during certain treatments, or in oncology, we can perform image guidance during biopsies and external beam radiotherapy. So in addition, we can even consider performing endobronchial ultrasounds, where we image the lungs from within the lungs themselves. And these are just the areas that we are actively pursuing at the moment. Optical ultrasound imaging can bring vast improvements in all of these areas and more.
Thank you very much, Erwin. Now, finally, over to you, Fraye.
Thank you. Movement labs provide gold standard information that people like me are working hard to replicate with wearable devices. So it's common for research to start in the lab first. Last year, I ran a small pilot study that used healthy volunteer participants who walked on a treadmill whilst I used motion capture cameras and infrared markers to measure their balance. Volunteers walked 3 times, once as normal, once wearing a brace that held their torso in a fixed straight position, and another time where the torso was held in a curved position, like a simulation of scoliosis. Although no humans were harmed or injured in any way during the collection of this data, I found that participants that walked in the simulated scoliosis, the curved condition, had worse balance when they were walking compared to the other conditions, which is what we've seen in scoliosis patients. So the next steps for me are to repeat this experiment using the wearable device and then to repeat everything in children with scoliosis.
Terrific, thank you. So we've got to kick out one of these 3 people. Let us start. Cast a vote. Give us a wave if you'd like to say goodbye to Fraye. Go for it, judges. Beverly is casting 1 vote for Fraye. Oh, and Cristina. Okay. Erwin, if you want to kick him out, give him a big wave now. Luke is doing... Oh, it's Luke and Edre are both voting for it, so we have a tie. We can say, Ellie, that you are safe at this stage. Audience, we're going to open it for you now. We're going to launch a poll. I'm going to relaunch this one. Everybody's name will appear there, but I want you to either vote off Erwin or Fraye. So cast your vote there. Any votes you cast for the other people, it's not counted. You can consider it spite if you like. If there's somebody who you really didn't like, this is your time. So please, cast your vote. Is this the last time you want to hear Erwin or the last time you want to hear Fraye? I feel immense tension as I can see those blue bars shooting up and shooting down. And somebody, probably one of Rowan's lab partners, maybe this is a personal hit attack or just a bit of like behind the scenes academic rivalry, who knows. We give you 5 more seconds. 5, 4, 3, 2, 1. Erwin, I'm sorry to say we have to see you go. Please tell our public audience here why they've made the worst mistake.
Well, maybe not the worst mistake, because as with all the other research, it is at most as important, I would say. But there was one particular advantage of optical ultrasound that I haven't been able to cover yet, so allow me to abuse the traditional teleshopping slogan, wait, there's more. So I mentioned how we use light to generate ultrasound by shining light into an optically absorbing coating. So if you make this coating black, it absorbs all the light. If you make this a specific color, like for instance purple, you can make light of one color be absorbed while other light is basically transmitted unaffected, which then allows you to deliver this light into the surrounding tissue where you can use that to perform treatment using the same instrument. You can improve efficacy of pharmaceuticals using photodynamic therapy, or perform complementary, what is called photoacoustic imaging, that not only reveals where tissues lie, but also what they are composed of. So over time, I see optical ultrasound sensors to develop into the Swiss Army knife of minimally invasive surgery, but one that is made at WEISS, at UCL, but not in Switzerland.
I see we've a raised hand, and I can't quite focus in on you. If you do have a question, please stick it in the chat. If you've got any questions for Rawen, or I can also see there's ones in the Q&A. I have flagged that we've got a question for Ellie later on, and another one for Ellie later on as well. We'll hear from them very soon. Is there any questions for Erwin at this stage? No? So sorry, well, there may be questions for you at the very end, Erwin, which is not very far from now. So please switch off your camera. We'll see you very soon. Goodbye. Okay, it is the final. So, Ellie, Fraye, you'll have 1 minute. Your last chance to impress on our judges and our audience at home that your research is the most important. Consider this your opportunity to get like a bit of slide work in that next grant that you're working on. You know, you can evidence that. You can cite me as a co-author if you like, just saying. But get ready to go. Please take it away. Fraye, you've 1 final minute. Tell us why your research is the most important now.
Okay, so in the last 5 to 10 years, wearable devices have become more accurate, more accessible, and more cost-effective. A wearable device can be worn continuously at home and provide real-time objective health data from a patient's normal environment. By harnessing this rapidly developing technology, we can provide a better, more personalized and patient-centered treatment and monitoring plan, whilst also reducing the time that a patient needs to spend in the hospital. For people with adolescent idiopathic scoliosis, this could be by reducing the number of x-rays they need to have by measuring their balance as they go about their normal day. But even more excitingly, measuring balance using my wearable device or measuring another movement type using a different device means we have the potential to help patients with many other disorders that affect the way they walk, navigate, and interact with their environment. Wearable technologies has so many applications in healthcare, it just needs the time and support to do so.
Thank you so much. And over to you, Ellie, for your final minutes.
Okay, so in summary, our ultrasound has lots of advantages and it's a great way to treat brain disorders for lots of different reasons. So firstly, it's non-invasive. So you focus the ultrasound through the skull from the outside. And there are a couple of different ways that it works. So in one way, which is already a clinical treatment, you generate a bit of heat and it destroys a small area of the brain and stops tremors. So we can also use it to push a bit on the neurons to generate more signals or suppress activity, but without causing any damage. And this is the thing that we're investigating at the moment. So it has few side effects. There are no drugs. So you lose some of the nasty side effects. There's no recovery time afterwards, and it generally improves the patient's quality of life. The costs are lower, saving money for the NHS, and it's specific. You can target inside the brain better than other similar technologies. And our system in particular has a better kind of range that it can pick from within the brain. So this kind of healthcare technology and this kind of ultrasound treatment is vital for addressing the so-called neurological time bomb associated with our aging population.
Fantastic. Thank you very much, Ellie. So, judges, this is our final decision. I'm tempted to actually open this one up to the audience to see if they get the final say as well. So I may, are you happy to do that, to give over your autonomy in this case? All right, everyone. The poll will be launching just now. You have to vote off Fraye or Ellie. Your vote is kicking them out. Alrighty? On your marks.
We're not allowed to vote, are we?
Not this time.
Oh.
No. Thank you so much. Your votes are voting the person off. Here's your last chance. You'll also be able to look at the expressions in the faces of our judges to see if they agree with you or if they don't. I'm going to give you another 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And with 70% of the vote, Fraye, you are out. I'm very sorry to hear that. You got right to the very end. Please tell everybody why they were making obvious mistakes. We also have a question for you ready, and if anyone's got any other questions, pop them in the chat. We'll get to them soon. But please tell us why we made such a mistake.
Well, I feel quite fortunate because I was able to say all of my bits, but at the moment, so the research is forming part of my PhD, and at the moment we're at a really important stage where we're moving from a simulated scoliosis that I was describing, that we simulated using a brace in healthy participants, but now hopefully sometime soon we're actually going to start doing this in clinical adolescents with scoliosis. So I'm really excited to hopefully see that our results translate from our pilot studies actually into the real world. And as Rawen said earlier, it's really important, that stage, getting research from a lab environment into the real world. So yeah, and congratulations, Ellie, your research sounds fascinating.
Oh, good grace there, Fraye, I think. Fraye, before we continue though, we do have a question. I think there's a dog somewhere who's a question as well, by the sounds of it. We'll answer the question as soon as we can. Fraye, you do have another question actually coming from Monica. She wants to know, why did you pick your research area? My research area is my PhD, so part of it was a PhD that had some funding that was available. My background is actually in veterinary medicine, and when I worked there I looked at gait and sort of how dogs walk and how lame they are. Obviously a dog can't tell you that it's lame, can't tell you how sore it is, and often they try and hide it in mysterious ways. So I was actually looking at movement analysis in a movement lab with dogs, and so I was just interested in that, and you know, a dog was a patient and a human is a patient as well. So I was interested in using the way that people move in their normal environment, and measuring that with wearables, as I said, at home seemed to really make sense to me. Did you actually give that answer to answer the dog as well? That was incredible synchronicity. You managed that.
Oh yeah, that's yeah.
By
that's
the way, I need to tell you something. My dog actually has really bad gait. She's had a knee done and actually walks really peculiar. So that's very funny. It was my dog barking. So
well, their contribution was perfectly pitched and perfectly timed.
Yeah.
Fraye, I know that's only going to be for a few seconds, but I think you have to ceremonially switch off your camera.
Good. Thank you very much.
Then there was one. Congratulations, Elly. Your crown is in the post. I would give you it right now, but we can't move within 2 meters of each other for that. Was there anything else that you feel like you've missed? Was there any final nuggets that you wish you had a chance to share with our panel and our judges here?
I'm not sure. Yeah, I mean, as Fraye said, I got to say everything that I planned to say. Yeah, but we are, so we're starting. We will be recruiting soon for a human trial to test this this amazing system out. So we're already running one with a simple system to see if we can look at the effects in human brains, and then we will be moving on to healthy volunteers and then eventually Parkinson's patients, hopefully as well. So it's coming.
Thanks so much. Actually, you're saying you don't have much room of more to say, but we do have a couple of questions already here for you. I'm going to read them out because I'm not too sure if you can see them, Dan and Amy. But the first one I think is probably the best one to begin with. Monica wants to know, can you explain, Elly, very quickly, in a sentence or two, how does ultrasound actually work?
So that is a good question. So for some of the mechanisms, it's very well understood. So if you want to generate heat with ultrasound, then that's a well understood mechanism and you can control it quite well. So it's kind of like focusing sound with a magnifying glass. Like if you were trying to light a fire and you had a magnifying glass and you focus the light, then you can make it very hot at the point where the light focuses. So you can do that with sound as well. So the tissues of the brain will absorb some of the energy and they turn it into heat, and then you can heat up a tiny spot and you can use that to destroy the brain. So the other thing that we're looking at is a different mechanism. So it might be just that you're vibrating or pushing on the brain cells. Still a subject of research.
Just picture some scouts shouting at some kindling. It's incredible. Elly, we also have a question from Carol. She wants to know, how long does treatment of ultrasound, the kind of you're describing, how long does it last?
So it would maybe, to actually do the treatment, we're talking about a few hours probably. I think for some of the clinical treatments at the moment that are already used, they do it within a day, certainly. So it's a day case kind of treatment. But yeah, the actual stimulation probably only lasts a few minutes. But there's a lot of, getting people into the equipment and into the MR scanner if that's necessary.
And finally, one more question, bearing in mind that your argument has been so convincing. Daphne would like to know if there's any downsides to ultrasound.
That's a really good question, actually. Yeah, I mean, maybe the effect or the something that's common with lots of new treatments, that people haven't used them much before, and there's not a long history that says this is exactly how we do it and this is going to work. But yeah, in terms of side effects and stuff, then yeah, it's fairly good.
We're being inundated by questions. Dan and Amy, can you see the ones which are in the questions and answer session?
We like to ask questions.
Okay, we'll give Cristina one. And if you can't see these, Amy and Dan, I'll give you the other ones so there's other voices rather than my beautiful brogue. So first to you, Cristina.
Is it permanent, the effects from the treatment?
The treatments that they do for essential tremor, where they're actually destroying a tiny part of the brain, then I think that is permanent in that you've destroyed that bit of the brain, but I don't know whether the brain then rewires itself eventually. The particular mechanism that we're looking at would not be permanent. So depending on exactly how long you run the stimulation for and the way that you do it, it might last only a few minutes or maybe up to 6 months or something like that. So it would be, it's reversible.
Before Dan and Amy give us some more questions that are coming in, I would love everybody who's here to please switch on your camera again, all the contestants, because we're going to let people have another go at you in case they didn't get a chance to ask questions earlier on. So if you've got any questions, please pop them in the Q&A section or in the chat. Just make sure that you tell us who they're for. Can you give us our next question, please, Amy?
Sure. So we do have another question for Ellie asking, does the ultrasound technique work everywhere in the brain or only close to the skull?
So one of the advantages of our particular system actually is that we can reach the very middle of the brain. So it isn't limited to the outside at all. Yeah, actually with some ultrasound systems, it's the other way around, that you can really only get into the middle and you can't move off to the side. But with ours, you can reach quite a good chunk of the brain.
Real. Dan, is there any more questions? And remember, they don't have to be for Ellie at this stage, though she is basking in glory. She is enjoying every minute of it. Thank you.
Ellie's very popular at this stage, but we do have some back from earlier in the event for Jeremy. Is Jeremy still about? Can I see him?
Jeremy's here.
Hey, so you've already answered one of them, but we have two questions. Firstly, are there any well-known medical or surgical devices that are known to have been badly designed for the user?
Okay, so the Da Vinci robot is a robot that's commonly used in surgery now. It's a big robot, and when the surgeons use it, they're immersed in an environment where they're controlling it, and they're tethered to the robot, and it gives the surgeons all the benefits that a robot can give, but unintentionally it's caused other issues in the surgery because they didn't think about, well, they would have thought about it, but it unintentionally caused communication problems between the surgeons and the nurses. And there's a lot of research of nurses are trying to do something and they'll get bumped by the robot because they're still by the patient, or the surgeon will ask them to do something and the nurse will go about doing it as they typically would, but without communicating to the surgeon that they're doing it. And so it causes a few frustrations. And these are things that just aren't known until you start putting them into practice, but we need to look at everyone who's in the environment about what's going on so we can come up with full solutions.
Thank you, Jeremy. I think it's amazing that there's a Da Vinci robot. It just sounds like Dan Brown's eventual sci-fi novel, doesn't it? It's going to happen. I can see there's a question there for Rawen. I don't suppose you could take that for us, Amy? Or if not, I think you may have frozen. Is it me or is it you, Amy?
Oh, hi. Can you hear me okay, Simon?
Yeah, okay, I'll give you it if you don't mind, Rawen. There's a question for you, which is actually, how are some cancers detected? I think Amy is frozen.
So in terms of why cancers can be missed during colonoscopy, so some of these polyps are very, very, very subtle. So they come in different shapes and sizes, different colors, different surface texture, and it's a very dynamic environment inside the colon. So it's not a pure cylinder shape. It really does move quite a lot. And you've obviously got a lot of artifact in there in terms of mucus and stool. So you can see how when you're going through this very long colon, you can very easily miss a small 5 millimeter, 10 millimeter lesion. And so that's the main ways that it's missed. It's either something's obstructing your view, such as the artifacts mentioned, or number two, it's within your vision, but your eyes have not detected it because it's so subtle. And particularly in the second case, that AI becomes useful because it's able to then alert you that, hey, in the top right corner there's a little lesion.
I'd like to point out we're actually now just reaching the normal concluding time for this event. So we will try and wrap it up, but also this is the internet. That's the good news. If you have to go off elsewhere and you're finished off, thank you for joining us. Feel free to sign off. But we'll take perhaps a few more moments just to ask some final questions. I can see that there is one here for Rawen again. Would you mind asking this question, please, Amy?
Sure, I think this is the right one because I lost you there and my internet cut out, but this is the most recent question. So, can you say what your view is on the competitive relationship in medical AI research between China and the US or Europe? Is this a zero-sum game, or does the patient benefit irrelevant of where the new technology is developed?
So I think that's an excellent question. I think in terms of, I'll answer the second part first, which is, it's probably not irrelevant where the technology is developed because with artificial intelligence, you train the software using data, and that data is normally collected locally. Patients are different, whether that's in Europe, US, or China. We have different characteristics. So it is important to get a data set that's similar to your population, number one. But secondly, in terms of the competitive relationship between China and Europe, I think it's good because we push each other as all academics do. But what I would say is I think there needs to be better collaborations. There are slowly collaborations developing between the West and East, but the biggest problem with artificial intelligence is you need a big size of data. And really the first way of getting over that hurdle is by having a better working relationship between as many academics as possible. So rather than competition, I think that we should use our interest to try to work together to create the best AI technology we can.
I think we're going to have to wrap it up here. So to give one final question, surely to our winner, Ellie. So I'd like to ask Mike Rowe's question, which is, Ellie, is the patient conscious during the treatment?
Yes. Yeah. I think in some of the clinical treatments, the patient is sedated but conscious because they have to ask them to do things to check whether or not it's worked. So I think that's usually the idea with brain surgeries, that you might be able to ask the patient to move their arms or say something or look at something. Yeah.
Okay, then there only remains one sort of final thing for us to do, which is to say thanks and massive congratulations to Ellie. But actually, it is true to say all these researchers are winners because they are winning grants and getting to do this research. And this is the kind of thing happening at WEISS at UCL that we hope one day will benefit clinicians and patients. If you've enjoyed today, then please keep your eye out to the WEISS events page. I will copy that in right now and to the UCL events page as a whole. We'll be doing another event like this on November the 18th. So if you give us a follow, you'll hear all about that. And before we go, I have to read you out the names of everybody who's been involved so we can give them a massive round of applause, whether they can hear it or not through Zoom. So a big thank you to Edric Kader, Beverly Power, Luke Buffery, Cristina Serrao, Ellie Martin, Erwin, Fraye Watson, Kader, Jeremy Opie, Sophia Bano, Amy Warnock, Dan Taylor, and to all of you out there for joining us. When I end this meeting, you'll get a short feedback survey. It will open in your browser. Please fill it in for us if you can. We'd love to learn how to make these things better. I have been, and am for that matter, Simon Watt. We will see you next time. Thank you ever so much.